All right, so now we're going to talk about the second method. It's called expanded notation, and a lot of people do like this way, so pay close attention. This might be one that you prefer. So looking here, we have 3,822 divided by 7, and if you look here, we're just going to have it like the traditional way, where we have our little symbol here to separate and think about now how many times can 7 go into, and once again, we just want to look at the first couple of numbers. Don't worry about the whole number here. And so 7 goes into 38 roughly around 5. So then I can just tack on my 2 zeros here. So really, we're going to think about 7 times 500 now is going to give me 3,500. So we're going to put our 3,500 right below our whole number. And once again, just like we did with the rectangle section way, we're going to subtract again now. So we are going to get 322. And now, instead of just moving to the right, we're going to keep that number right there and just once again think about, well, how many times does 7 go into now 32? So roughly it is going to go in about 40 times without going over. And 4 times 7 equals 28. We know our rule about adding 0 or multiplying zeros, so we're just going to tack on that 0 at the end. So once again, we're going to subtract, and if we do, we get 42. Now this time it's going to seem like a much more doable number. So 7 goes into 42 6 times, so that will end up right there. And 7 times 6 once again is 42, and if you subtract those, you're going to get 0. Now remember, just once again though, like if you ended up with a number smaller than 7, that would just turn into your remainder, we would call it. So now we have numbers that look like this, and if you just add up all of these numbers, you're going to get 546.
And that should look familiar.
Yes, because in the first part we showed you this problem. So we just wanted you to see that we can do the rectangle method over here, or this way is a little bit shorter. So some of you might prefer, now that you're getting more familiar, doing the expand.
So if you look at the first box here, it's the same as this part right here. And I know like this part looks like it's missing. This little red dot is just from where I took the picture, showing it zooming up here. So if you imagine this part saying 322 minus 280, that should look familiar here. So really each of these little parts goes into each of these little rectangles. So just if you want to you see the connection between the two. Okay, so now you get to try one on your own. So for the first one, or for the one you're going to try and pause, is 7,533 divided by 9. So start by setting it up as a division problem, and then try it. Try it, go back, watch our step by step. If that helps you, just follow the same steps, different numbers. So go ahead and pause and try it, and we will go over it in a second. Okay, so like we did before, we're thinking how many times is 9? If I look at the first number 7, 9 doesn't go into 7. So I'm going to need to look at the next one. So how many times does 9 go into 75? So if I think about 9 times what gets me close, it would be 9 times 8 gets me to 72, and then I just got to tack on my 2 zeros there. So 9 times 800 is 7,200. We subtract, and we end up with 333. So now again, I'm looking at how many times does 9 go into 3? It doesn't, so I got to look at the second digit too, 33. So 9 times 3 gets me close to 33 without going over. So 9 times 30 is 270. And if we subtract that, we end up with 63. And now, I know this one, 9 times what gets me close to 73, or 63, it actually gets me exactly there, would be 7. So 9 times 7 is 63. Subtract, and we end up with 0 as our remainder. So we're not totally done yet. We have to now add these 3. These are like written out in expanded notation to get 837. So hopefully you guys all got that. And if you didn't, look back and see what you did wrong so that when you go on to do these on your own, you won't make the same mistake. So now there are 2 that you have to go do on your own, and honestly, I don't remember if they have remainders or not. They might, so don't be surprised if they do. But go through, try and use the expanded notation to solve this. And even if like rectangle sections is easier for you right now than expanded notation, try expanded notation. And in the
Give it a
end, when you go to take your test, you can choose whichever way you want.
Mm-hmm.
We just want you to try the different methods to see which one makes the most sense to you. So go ahead, give it a try, and we will go over these tomorrow. Good luck.